Okay, welcome to the red packet. So this one is all about linear systems, and today the notes are Acquire 1, Solving Single Variable Inequalities. So in the last unit, we solved equations with one variable. So let's just do a little review. Right now, this 6 and this n are being multiplied. The opposite or the inverse of multiplying is dividing. So I'm going to divide by 6 on both sides. When I take 6 and divide it by 6, that's a 1. So I've got n equals 6. I get one answer. For the second one, the first thing I want to get rid of is adding or subtracting. So right now, this adding 10 right here, I want to get rid of that. The 2 is attached to the n, so leave that be. If I'm adding 10, the way to get rid of it would be to subtract 10 on both sides of our equal sign. 10 minus 10 is a 0, so 2n plus 0 is just 2n. 34 minus 10 is 24. Divide by 2 on both sides because 2 and n are being multiplied. To get rid of it, I divide. I've got n equals 12. This last one can be solved in multiple ways. So I want you to try it on your own. At the very end of this lesson, I will come back and we will talk about, or I'll show you the answer. So that's how you solved equations. We're going to be talking about solving inequalities. First, let's talk about what an inequality is. An inequality, so it means it's in equal, not equal, is like an equation. An equation has an equal sign. Except instead of the equal sign, you have one of these four options. We've got less than, greater than, less than or equal to, or greater than or equal to. So equation means equal. Inequality means it's got to be one of these symbols. It's not equal all the time. Sometimes it's greater than or less than. So instead of just one solution, like up here I have one number, we have a solution set. That means we have more than one answer or solution. Remember, if I am going too fast, pause the video, write it all down, and then listen again to how I'm explaining it. So let's see when equalities show up in real life. Andre is going to the state fair with his friends. He can spend no more than $35 on rides, and each ride costs $4. Can Andre ride 5 rides, 8 rides, 10 rides? Well, let's think about this. If he rides 5 rides, that means each of them costs $4 times those 5 rides. That's $20. It says he can spend no more than 35. Is 20 less than 35? Yep, he can ride 5 rides. How about 8 rides? So $4 times 8 rides he's going on is $32. Can he ride 8 rides? If it's less than 35, yep. Let's talk about 10 rides. 4 times 10, that gives us 40. Can he ride 10 rides? No. $35 is all he has. So he can't spend 40 if he only has 35. So he cannot ride 10 rides. So let's create an inequality about the situation to learn more about it and to write it in a better way. This part right here is super important. No more than $35. That means he can use less than $35 and he can also equal $35. But he can't spend more than $35. So we know He can have less than or equal to $35. He can spend that much. Now let's look at what we wrote over here. We said it was $4 times the number of rides. We could use R for the number of rides. So I wrote my little variable over here. We're going to say 4 times R is less than or equal to 35. And that's basically what I wrote over here. I plugged in 5 for R. If it was less than 35, it worked. So now let's talk about what happens if we change what's on both sides of our inequality. So right here we have a number line and we have all these things we're going to change. We are starting with 3 is less than 5. If I find 3, so I'm starting at 3, and here's 5. That's true. 3 is in fact less than 5. But what happens if we add 2 to both sides? Let's take 3 and add 2. Less than 5, add 2. So I took 3 plus 2, and I have 5 plus 2. 3 plus 2 is 5, and 5 plus 2 is 7. Is 5 less than 7? Yep, it checks off. So if we add to both sides, nothing happens. It's still true. If we subtract 2 from both sides, let's see if this is still true. So I'm starting over from this one. I've got 3 minus 2 is less than 5 minus 2. Well, 3 minus 2 is 1. Less than 5 minus 2 is 3. I just simplified both sides, kept my symbol. Is 1 less than 3? Yep. So subtracting the same thing on both sides did not change anything. Our symbol didn't change. It was still a true statement. We tried adding, we tried subtracting. Let's try multiplying. So I've got 3 multiplied by 2 is less than 5 multiplied by 2. 3 times 2 is 6. Less than 5 times 2 is 10. If you don't know what these are, whether it's adding, subtracting, multiplying, or dividing, type it in your calculator. You have it. Is 6 less than 10? Yep. So multiplying by 2, our symbol didn't change. Our whole thing was still true. Let's try multiplying by a negative 2. Let's see if this changes anything. What we're trying to do here is to see if there's any rules that we need to know before we start solving equations. So let's try multiplying by negative and see if that changes. 3 times negative 2 is less than 5 times negative 2. So if you need your calculator, get it out now. 3 times negative 2 is negative 6. Less than 5 times negative 2 is negative 10. Is negative 6 less than negative 10? If you're unsure, we put this number line at the top so you could see it and use it. Here's negative 6. Here's negative 10. Is negative 6 less than negative 10? No! Negative 6 is closer to 0. This is like your less side. This is your more side. The number that's on the left is less than the number that's on the right. So this is not true. Negative 6 is less than negative 10, not true. We could change it though, and we could say negative 6 is greater than negative 10, and that would be true. So all I did was take the symbol and I flipped it the other direction. That's how I made it true. It wasn't true until I changed it. Let's try dividing. So I still am using 3 is less than 5. So 3 divided by 2 is less than 5 divided by 2. Now right now it might be hard to tell which one's greater, which one's less. So in your calculator, you can find it by typing in 3 over 2, then hitting Control and Enter. it should give you a decimal of 1.5. Less than, do the same thing over here. This one's going to give you a decimal of 2.5. Is 1.5 less than 2.5? Of course. Ooh, this one over here, we're dividing by a negative. Let's see if it's similar to multiplying by a negative. I still have 3 on this side. I'm going to divide it by a negative 2. Less than 5 divided by a negative 2. 3 divided by negative 2 is this, but it's negative. So negative 1.5 is less than negative 2.5. So let's see if this is true. I'm going to go up to my number line. Negative 1.5 is right here, in between negative 1 and negative 2. Negative 2.5 is right here in between negative 2 and negative 3. Our inequality is telling us that negative 1.5 is less than negative 2.5. Remember, I told you the one on the left is supposed to be less than. So this one cannot be less than. This is not true. But once again, we could change it. We can say negative 1.5 is greater than negative 2.5. And that is one way to make it correct. So let's write a little conclusion down here. Did anything change when we added, subtracted, or when we multiplied or divided by a positive number? No. So all of these are fine. These are the only two that we need to change the symbol. So we're going to say, when you multiply or divide by a negative number, you need to flip the inequality symbol. Okay, I know that was a lot. If you need to pause the video, pause it and write this down. When you multiply or divide by a negative number, you need to flip the inequality symbol. And you can look at example 4 and example 6 as an example of that. So let's look at some of our examples over on the second page of Acquire. So this is still notes, but now we're going to try some actual examples, like the full thing. So we are solving these problems. That means you need to get x, or the variable, by itself. Variable by itself. I'm going to zoom in a little bit so maybe you can see better what we're looking at. So using the same type of rules as solving an equation, I'm going to solve this. I've got 4 times x is less than 28. If we have 4 times x, to get rid of times, we have to do the inverse or the opposite. That means we're going to have to divide on both sides by 4. 4 divided by 4 is 1. So I've got 1x is less than 7. That's my answer. Now, does x equal 7? No, there's no little equal sign below here. So x cannot equal 7, but it can equal anything less than 7. So it could equal 6, it could equal 0, it could equal negative 37. As long as it's less than 7, it works. The way to check that your answers are correct over here to make sure x equals 6 is actually the answer is to plug it back into the original problem. So we've got 4x, so I'm going to plug in 6. Remember, I chose that answer. We're going to see if it's true. 4 times 6, 24 is less than 28. Check, it works. got 4 times 0. So 4 times my x is 0, less than 28. 4 times 0 is 0. 0 is less than 28. Check. This last one, 4 times negative 37 is less than 28. Use your calculator, figure out what 4 times 37 is, or negative 37. It's going to be negative 148 is less than 28. Is that true? A negative number is less than a positive number? Yep. All of our options work. Let's try number 2. So for this one, it is almost the same as number 1. But now we have a negative 4x. So negative 4 times x. To get rid of times or multiply, we divide on both sides by negative 4. Divide by a negative, woo, woo, woo. That is a sign that you need to flip the symbol. So negative 4 divided by negative 4. We get 1x. We need to flip our symbol. We had less than, now we have greater than. 28 divided by negative 4, negative 7. So now we need to pick some options that are greater than negative 7. I could pick negative 2, because if you look up here at your number line, here's negative 7, here's negative 2. The one on the left is less than. So negative 2 is greater than negative 7. I could pick 32, or I could pick 1,000. 1,000 is definitely greater than negative 7. So in order to check these, I'm going to check just the first one, but you should be checking all of yours to make sure that you picked good numbers. I'm going to take this x, and I'm going to plug it into my original. So negative 4 times negative 2 should be less than 28. Negative 4 times negative 2, positive 8, is less than 28, which is true. Okay. On number 3. This time, the x is on this side. That's completely okay. Not a big deal. But the x is being divided by a 4. The opposite or the inverse of 4 is to multiply by 4 by every piece that we have. X over 4 is one piece. I'm going to multiply by 4. Negative 66 is another piece. I'm going to multiply by 4. Now you're just simplifying. So 4 times negative 66 is negative 264. Did we multiply by a negative or a positive? We multiplied by a positive, so our symbol stays the same. So less than or equal to x, because we had 4 and a divided by 4. Now, this is kind of hard to read. It's backwards. So I am going to switch the whole thing around. I like for the x to be on this side. So I'm going to put the x over here. I'm going to take my symbol. Right now it opens up towards x. So it needs to open up towards x again. And I'm going to put the other number on the other side. So this is our final answer. And all we have to do is pick things that are greater than negative 264. So negative 100 is greater, 0 is greater, and positive 264 are greater. When you work on the apply or the practice part, you are not guaranteed to have the exact same numbers as someone else. If your numbers are greater than negative 264, they work. Okay, let's try number 6. So I'm going to jump around a little bit. At the very end, I will show you the whole page with all the answers if you would like to try them yourself, and you can stop at the end and check your answers. That's great. Let's try number 6. So the first thing I'd like to do is get rid of this 5. The 20 is still attached to the x. So to get rid of adding a 5, the inverse would be to subtract the 5 on both sides. So 5 and minus 5 turn into a 0, so I'm left with x divided by 20. Then I have less than or equal to 6 minus 5 is 1. Now I have an x divided by 20. To get rid of this divided by 20, I'm going to multiply all the pieces by 20. This is a piece, this is a piece. 20 divided by 20, just a 1. So we have x is less than 20, or equal to. So on this one, could we equal 20? Sure, we've got an equal to. I could be equal to 10. I could be equal to negative 100, as long as it is less than 20. Okay, let's get to number 9, and we'll finish with number 9 and number 10. This one, got a lot going on. So I'm going to walk you through these steps on how to solve this. The very first thing I do on any solving equations is to distribute. So I'm going to take this 3 and distribute it to the 8 and the x. I'm going to rewrite this side because I didn't change anything. Keep my symbol. 3 times 8 is 24. 3 times x is just a 3x. My second step when I solve is to get the variables that are alike on the same side. So remember, we like to have our x's on this side of our equations or our inequalities. So I'm going to move this 3x from this side to this one. To get rid of a positive or a plus 3x, I need to subtract 3x on both sides of my inequality symbol. This one turns into a 0. This is greater than 24. We still have a 33, and we have negative 6x minus 3x. So I've got minus 9x. Now I'm just solving for x like normal. So to get rid of the 33 and the negative 9, first thing I want to get rid of is this 33. The negative 9 already attached. I'll get rid of that later. This is a positive 33 because the negative goes with the 9. So to get rid of a plus 33, I'm going to subtract 33 on both sides. So this becomes a 0. Negative 9x is greater than, and in your calculator, find out what 24 minus 33 is. You should get negative 9. We've got negative 9 times x. To get rid of times or multiply, I have to do the inverse, which is divide. So I've divided on both sides by negative 9. Woo, woo, woo! If I'm dividing by a negative, that means I have to flip my symbol. So we went from this symbol to this one. Negative 9 divided by negative 9 is 1. My final answer is x is less than 1. Can we equal 1? No, we don't have an equal sign. So I could say 0, negative 1, negative 42. Does not matter. Remember, you can check your answers by plugging it back into where the x was, both of them. Number 10, last one. We have even more going on in this one, so just follow my steps as we go through this. First step, I need to distribute. 2 times 1 is 2. 2 times 2x is positive 4x. Bring down the 3x. Bring down the symbol. Negative 12 plus 9x. Okay, before I start moving these x's around, I want to simplify what I have on my sides. So I've got 2 plus, what is 4x plus 3x? 7x. I can combine them because they both have x's. I'm still keeping my symbol, and I've got negative 12 plus 9x. Now remember, we like for the x to be on this side. So let's try to get all of the x's over to the left side. I have adding 9 over on this side. To get rid of that, I'm going to subtract 9x, can't forget the x, on both sides. So 9x minus 9x, 0. I just subtracted, so I'm not going to change my symbol. I've got negative 12 on this side, it just stayed the same. On this side, I've got 2, and then I've got 7x minus 9x. Just going to give us negative 2x. Okay, now I'm solving for x. I got to get rid of addition and subtraction first. This 2 over here is being added. Remember, the symbol that's in front goes with it. So this is a positive 2, this is a minus 2. To get rid of this positive 2, I'm going to subtract 2 on both sides. 2 minus 2 is 0. I've got negative 2x is less than or equal to negative 12 minus 2, negative 14. Negative 2 times x. To get rid of a times 2, or a times negative 2, I need to do the inverse, which is divide. Divide by negative 2, divide by negative 2. X. Oh! Wee! Because we divided by negative 2, what was I supposed to do? Flip my symbol. See, even math teachers mess up. That was just a test. So we've got x on this side, because these negative 2's went away. Flip your symbol. Negative 14 divided by negative 2 is a positive 7. We are looking for things that are greater than or equal to positive 7. So one of our x values could be 7. It can equal. We could have 8, and we could have 9. Okay, if you would like to check your answers on the other problems, pause right here. I'm going to show you the answers in about 3 seconds. Okay, so I have completed the rest of the problems on this page. It will zoom out a little bit. I finished 4, 5, 6, as well as 7 and 8. So if you want to pause it right here, I finished 4, 5, 6, 7, and 8. You can double check your answers and make sure you are doing it correctly. So pause it and check. Now over here on the warm-up, I told you I would finish. If you wanted to know what the warm-up answer was, it was negative 5. Okay, flip to the next page. Your apply or your practice is just one page. It's exactly like what we were doing. There is equations, so you'll get one answer. There are also inequalities. You're going to get a solution set, and you can pick some answer choices that are correct. Good luck!